All right, so Friday we looked at a lot of evidence of Earth's having a supercontinent at one time. So, this one big, massive piece of land that contained all of the continents that we know today. But the naysayers, they really still had a lot of questions. And one of them was, how exactly do those continents move around in the mantle then? Like, what force is causing them to plow through that kind of solid, liquid mantle? So, in your makeshift ISN, I want you to pause the video for a second and I want you to sketch for yourself a diagram that looks about like this, making sure that you have each of those layers labeled. Once you've got it, you can unpause and we'll keep rolling. Okay, now thinking about our Earth and the research that you guys did on each layer a couple weeks ago, I want you to complete this sentence in your ISN using words from your diagram. Hotter temperatures are found near the blank of Earth, and cooler temperatures are found near the blank of Earth. Now, we've got these hotter and these cooler temperatures that are even within the same layer, right? The mantle is considered one layer, but we've kind of got an upper mantle and we've got a lower mantle. So, depending where they are compared to the center of Earth, because heat is moving outward from that extremely hot center of our Earth. So, I want you to go ahead and sketch that with me on your diagram here, where our heat is moving outward from the core. So, in your layers of Earth research, you all told me that the mantle is kind of liquidy, and we even saw in our Oobleck lab that a liquid-like state is possible depending on different things like force and maybe even a little bit on heat. So, let's see what happens when hotter and cooler layers of our Earth meet. All right, so I've got here two bottles of hot and cold liquids. So the hot liquid is a warmer color. The cool liquid is a cooler color. See what I did there? Okay, now I want you to watch what happens when I put the two of them together, just like when we have a hotter and cooler section of our mantle put together. Okay, now, only thing separating them is our playing card. Hold up. And can you see that okay? I think you can. Go. We'll see if we can't move. Is that going to stay? Yeah, it is. Okay, we're going to move this a little bit closer so you can see exactly what's going on here. Just got to watch for a little bit. I want you to look at those colors. Kind of see what is happening here. So notice what's happening with the cool liquid and what's happening with your warmer liquid. Okay. Alright, now I have one more trial. Oh, this is precarious. Oh, this is not a good idea. Okay. We got it. We're great. Okay, so that one's sitting right there for you. Now we've got one more trial, but this time I want you to pause the video just for a second, and I want you to think about what is going to happen if I flip-flop the way that these are stacked here. So if I stick this one on top, what do you think? This is not easy. Okay, here we are. What do you think is going to happen when I remove the playing card this time? Okay, you have it in your head? Alright, let's see. We'll just leave it there for a couple seconds. So, difference between our first trial and our second trial. No, let's stay out of there. Oh, dog. Okay. Hopefully your suspicions were confirmed, or maybe even something's clicking in your head about why on earth those liquids would do that. Okay? So in your ISNs, you're actually going to fill in the sentence here based on what you're seeing with these two trials. Hot liquid wants to move somewhere, and cold liquid wants to move somewhere else. Now, thinking about the molecules of hot substances that would have a lot of energy and the molecules of cool substances that would have less energy, I want you to fill in the blanks on this next line here. Blank liquid is heavier and more dense than blank liquid. Okay? So, the same thing that we are seeing happen with these hot and cold liquids is what happens in our mantle. As the center of our Earth heats the lower sections of that liquid mantle, the hot liquid rises, and our cooler liquid, which was on top, settles to the bottom. And it kind of becomes this cycle of energy known as a convection current. So, you're going to go ahead and draw some arrows with me on your diagram just so we can see how exactly that looks in our mantle. And you guys have probably heard this word before, but convection, where our hot liquid rises and our cool liquid sinks. Now, I want you to keep in mind that the Earth's crust is made of plates, and the continents are part of those plates. So, based on what we saw with our supercontinent evidence, I mean, obviously the Earth doesn't look the same today as it did then. So, those continents have to be drifting apart, slowly but surely. But it's those convection currents underneath, that hot liquid rising, the cool liquid sinking, that's going to trigger our plate movement. So the last thing that I want you to do for this page in your ISN, I want you to answer two questions for me. One is, where else do you see this idea of convection, of heat rising and cool falling? Where else do you see that in your life? Or maybe where else have you heard the word convection in your life? And then your second question is, what force is it then that's causing the plates to move around in the mantle, and why does that happen? So I want you to kind of summarize the video today, summarize what you saw in the demo, summarize maybe even what you wrote in your notes into one or two sentences to answer that second question. Once you've answered those two, I want you to either snap a picture of those last two questions, or you can type up the answer to those questions and submit it via Google Classroom. Now, if you look at your classroom assignment instructions, you've got one more little thing to do called continents over time. But once you have those two things done, you are done for the day. All right? So, love you guys, miss you guys, and I hope you have a great rest of your day.